Namaskar, welcome to the KTHM College Nasik and welcome back again to the lecture series of first year BSc Biotechnology course, Biophysics and Instrumentations. In the previous lecture, we have started to discuss on the atomic structure. We started with the history of an atom and we have seen the various models of atomic model according to their drawbacks and failure. Among them, the Bohr's atomic model is more preferable and most acceptable model. According to this model, atom consists of a smallest or tiny particle and it consists of positive and negative charge particle. The positive charge particle are concentrated at its central region called as a nucleus, and all the electrons, they are revolving around the nucleus. We have gone through the postulates of Bohr's atomic model, like electrons are orbiting in a circular orbit around the nucleus and hence it is continuously revolving around the nucleus in a fixed orbit, hence its angular momentum is constant, and electrons, they are orbiting in fixed orbit. So this is the nucleus, or we can say that the positive charge particles are concentrated called as a nucleus, and the remaining negative charge particles, they are orbiting in a fixed orbit having particular energy, and these orbits are denoted by the principal quantum number n is equal to 1, n is equal to 2, n is equal to 3, the principal quantum number. And each and every orbit has fixed energy, and these energy level diagrams we can draw. N is equal to 1 having particular energy E1, n is equal to 2 fixed energy. These are the energy level states, or we can say that these are the energy states having particular fixed energy, and so on. And there are n is equal to infinite number of energy levels. As the highest orbits, the highest orbit has more energy, higher energy, and hence its energy is negative for n is equal to 1, minus 13.6 electron volt, and the energy state, the energy of the last or infinite state is 0 near about. So when any external energy taken by atom, the electrons in the lower state, the electrons present in the lower state get excited and jump to the higher state, either n is equal to 2, 3, 4 or whatever it is, and the atom will get unstable. But according to the property of an atom should be stable. So within a short time, these excited electrons come back to the lower state. And we know that each and every orbit has fixed energy. So the highest orbit has highest energy. So while jumping from higher level to the lowest level, the electrons release some amount of energy during this de-excitation process. And that energy, released energy, is in the form of radiations. Or photon, we can say that. As we all familiar about, light is an electromagnetic wave, or it is also called as radiation or photons. So electromagnetic wave is nothing but energy. When the white light is coming from the source, it contains different kind of radiations according to the different frequencies and different wavelengths, and we know the relation between frequency and wavelength. So the photons, emitted photons having frequency or having relation energy is equal to h nu, where h is the Planck's constant and nu is the frequency of the wave, because light is nothing but electromagnetic wave, and it is also called as its behavior is also like particle, or we can call it photons, because we know the wave particle dual nature. Okay, light or radiations or wave has particle nature also, and particle also have wave nature. Okay, so E is equal to h nu and E is equal to hc by lambda, where c is the speed of light, which is equal to 3 into 10 raised to 8 meter per second, and lambda is the wavelength. Okay, if we draw the wave nature, displacement versus time. What is wave nature exactly? It's the oscillatory motion of the particles, and that is nothing but wave nature. And we can draw the wave nature like this. So the distance between two crusts here, we can say that the lambda. When the light is coming from the source, it is having full of spectrum and called as electromagnetic spectrum. So this electromagnetic spectrum has different radiations according to their increasing frequency or decreasing wavelength, because frequency and wavelength both are, if you compare these two equations, so we will get here h nu is equal to hc by lambda, or finally we can write nu is equal to c by lambda, where nu is the frequency of the wave and lambda is the wavelength of that. So they both are inversely proportional to each other. So therefore a radio wave having longest wavelength or low frequency or lower energy, microwave, infrared, visible, ultraviolet, X-ray, and gamma rays. So these are the full of electromagnetic spectrum having different radiations according to their different frequency and different wavelength. So the radio wave having longest wavelength or lowest energy, while gamma ray has lowest or short wavelength radiations or highest energy or frequency. So this is the full of electromagnetic spectrum. Now let's come to the point, origin of the spectral lines. So here we consider an atom, hydrogen atom, and it is having one electron and one proton here. So when any external energy taken by an atom, then the electrons get excited and it jump to the highest level or energy level or highest orbit, but within a short time it will jump back to the lowest energy. So this process is known as excitation and de-excitation of electron, or it is also called as electronic transition. So during de-excitation process, when electron while jumping from the highest energy level to the lowest energy level, it emit radiations in the form of electromagnetic wave or photons having energy E is equal to h nu, as we have seen here. So when the de-excitation occurs, means the electrons jump from higher energy level to lower energy level, because as we know that the highest orbit having highest energy. If we consider, this is the initial energy level or energy state, where electrons jumping from the highest energy level to the lowest energy level, if we consider E final state, because we are talking about the de-excitation process. In de-excitation process, electrons jump from highest energy level to the lowest energy level. So I am considering here, this is the initial state and this is the final state. So during this transition of electron, the energy is released in the form of photons or electromagnetic radiations. And as we derived the equation of energy, E is equal to minus m e raised to 4 upon 8 epsilon naught square h square and n I square. So this is the initial energy, okay, n initial, and E f is equal to minus m e raised to 4 8 epsilon naught square h square n final square. And the energy difference between, so how much energy is released? So this energy, because this orbit has fixed energy and this orbit also has fixed energy. So how much energy release here? Because electrons are present, initially electrons are present in this state and they want to jump and they want to come here, okay. So the difference between these energy levels is released during the de-excitation process. So here I can write delta E is equal to E initial minus E final. Okay. So if you put the values of these two, initial energy and final energy, so we will get minus m e raised to 4 upon 8 epsilon naught square h square n I initial minus plus here, so you will get m e raised to 4 upon 8 epsilon naught square h square n final square, where n final is nothing but the lowest energy level. So we can write here m e raised to 4 upon 8 epsilon naught square h square n final square minus m e raised to 4 upon 8 epsilon naught square h square n initial square. So here we can see the common terms, m e raised to 4, take it out, m e raised to 4 upon 8 epsilon naught square h square, and finally we can write 1 upon n final square minus 1 upon n initial square. So this is nothing but energy. This much energy is released during the excitation process, and we know that E is equal to h nu, which is equal to m e raised to 4 upon 8 epsilon naught square h square 1 upon n final square minus 1 upon n initial square. So take this h in this side, so nu is equal to m e raised to 4 upon 8 epsilon naught square h cube, because we take this h in this side. So 1 upon n final square minus 1 upon n initial square. Alright. So finally we can write, this is nu is the frequency, right, and we know that nu is equal to c by lambda. So c by lambda is equal to m e raised to 4 upon 8 epsilon naught square h cube 1 upon n final square minus 1 upon n initial square. Now let me introduce wave number, because we know that this is the wave nature, and wave number is denoted by nu bar. Only nu is the frequency and nu bar is denoted as wave number, and which is equal to 1 by lambda, because we know that this is the lambda and 1 by lambda is nothing but the wave number. Okay, so that wave number here we can write, we know that c by lambda is equal to m e raised to 4 8 epsilon naught square h cube 1 upon n final square upon minus 1 upon n initial square. So here c by lambda, we will take c here, so the remaining 1 by lambda is equal to m e raised to 4 upon 8 epsilon naught square h cube, and we will take this c in this denominator, so we will write here, and 1 upon n final square minus 1 upon n initial square. But we know that 1 by lambda is nothing but wave number, so instead of 1 by lambda we can write wave number is equal to m e raised to 4 upon 8 epsilon naught square h cube c 1 upon nf square minus 1 upon n initial square. So this constant is known as Rydberg constant, RH, 1 upon nf square minus 1 upon ni square. This is called as Rydberg constant. Where RH is calculated, and which is equal to 1.0968 into 10 raised to 7 per meter, right? So this is the Bohr's relation, 1 by lambda is equal to RH constant, Rydberg constant, 1 upon n f square minus 1 upon n I square. So with the help of this relation, we have seen the various spectral lines of hydrogen atom. If n initial state is fixed, means atom has taken energy and the electrons, they excited and jumped to the highest state, okay, n is equal to 3, 4, 5, 6 up to infinity. So if we fixed n initial state, that is the initial state, and while jumping the electrons from the initial state to the final state, so during that de-excitation the spectrum is coming out. So that we are going to discuss here. If n initial is fixed and the electrons jump from the fixed energy orbit to the variable energy orbit. So the first series is Lyman series. In these spectral lines, if n final means the highest energy level is initial state and the final state where electrons de-excited. So if n final is equal to 1, means electrons jump from highest orbit to the first orbit, n is equal to 1. So the final state is n is equal to 1, and n initial, it might be 2, 3, 4 up to infinity. So that means here, if you consider this is the initial state, an electron jump from initial n is equal to 6 to 1, or if n is equal to 5 is the initial, and it will jump from 5 to 1, and similarly here 3 to 1, similarly 2 to 1, right? So during this de-excitation, the photons are emitted, and this series of electromagnetic radiations is known as Lyman series. And these kind of radiations having the frequency in the range of ultraviolet region, UV region. I hope it is clear. The second series is Balmer series. Balmer series of hydrogen atom. So in a hydrogen atom, if electron jump from, if n final is 2 and n initial is 3, 4, 5 and either so on. So suppose for example electron jump from the highest orbit to the n is equal to second state, or it jump from the highest orbit to the second state, or this, or this. So during this process, some amount of radiations or energy released in the form of radiations. So these electromagnetic radiations are in the visible region. So this is the Balmer series. So UV region, visible region. Third series is Parkhe series. N final is 3 and N initial is 4, 5 and so on. So in this process, N final is third state. So the electrons from the highest orbit to the third state, electron jump from highest orbit to the third state and third state. So during this de-excitation, the radiations are emitted, and this is called as the Parkhe series, and these electromagnetic radiations are near infrared region, near IR region. And the last series is bracket series. In this series, N final is 4 and initial states are 5, 6, 7 and so on. So in this series, N is equal to 4 is the final state, and the electrons jumping from the highest to this state. So such kind of de-excitations emits radiations, and this is called as the bracket series, and the electromagnetic radiations are in the infrared region, IR region. The frequency of the emitted radiations are in the IR region. And the next series is the last one, fifth one, P-fund series. Yes. in this series n final is 5 and the n initial is 6, 7 and so on. So this series n is equal to 5. In this series electron jump from the highest orbit, and during this process the radiations are emitted having frequency in the range far infrared, far IR region, as we have discussed or as we have seen the electromagnetic spectrum, right? And this series is known as P-Fund series. So these are the series of the spectral lines of hydrogen atom, and you can see the energy level diagram. So thank you very much, and we'll see you in the next class.